Hello students, let's do a curve sketching problem. We're asked to discuss the curve y equals x to the fourth minus 4x cubed with respect to concavity, points of inflection, and local maxima and minima. Use this information to sketch the curve. So again, the equation is y is equal to x to the fourth minus 4x cubed. Now, you should also talk about the intercepts. I think it will not be a problem for you to all realize that the x-intercepts are the origin. C of x is 0, so is y. So we have 0, 0. But also, if you set this quantity equal to 0 and solve for x, you get another value, which is 4. So we actually have two x-intercepts, 0, 0, and 4, 0. All right, so now let's get on to the rest of the stuff. So we're going to need the derivative. So using the power rule, y prime is 4x cubed minus 12x squared. So what we're doing right now is we're looking for local maxima and local minima, which also means we need to know where the function is increasing and where it is decreasing. So what I'll do is factor this expression, so what I get is 4x squared times the quantity x minus 3. So why don't we draw a chart here for the first derivative. So we have two critical numbers. Remember, critical numbers are values of x where the derivative is 0 or where the derivative does not exist. So they are 0 and 3. So using test points, pick a value of x that's greater than 3. Well, the first derivative is positive. And if you pick a value of x that is between 0 and 3, well, x minus 3 becomes negative. And you should realize that x squared is never negative. So around 0, the derivative actually does not change sign. The reason is that, the factor that corresponds to x equal to 0 is x, and x is being raised to an even power. So that's why we're getting repeated behavior here. So what's happening with our function is our function is decreasing, and then we have a horizontal tangent line. And then at x equals 3, the function changes from decreasing to increasing. So actually we have only one local extrema, because a local extrema occurs when the function changes from decreasing to increasing or increasing to decreasing. So we're going to have a local minimum at x equals 3. Now, in case you're curious, let's plug in 3 into our original function. Remember, our function is y is equal to x to the fourth minus 4x cubed. Well, 3 to the fourth is 81. Then we have minus 4 times x cubed. Well, 3 cubed is 27, so what I have is 81 minus 4 times 27, which is actually negative 27. So f of 3 is negative 27. We're going to need that later on when we actually graph this function. Okay? So we have a local minima. We have intervals where the function is increasing and decreasing, but we also now want to talk about concavity. So to talk about concavity, we need the second derivative. So let's write down our first derivative again. The first derivative was y prime is equal to 4x cubed minus 12x squared. So y double prime is 12x squared minus 24x which can be factored as 12x times the quantity x minus 2. So what we're going to do now is make a chart for our second derivative. So the values of x where the second derivative is 0, which means we could possibly have a change in sign, and if we do, that's called a point of inflection. Okay, so y double prime is 0 when x is 0 and when x is 2. If x is greater than 2, the second derivative is positive. If x is between 0 and 2, the second derivative is negative. If x is less than 0, what we have is a negative times a negative, which is a positive. So what that tells us is that our curve is going to be concave up if x is less than 0, concave down if x is between 0 and 2, and then concave up again if x is greater than 2. So what you can do is, just sketch it using all of this information. We have everything we need. You could treat a little bit using Desmos. If you use Desmos, this is the picture that we get. Okay, you see that at 0, the function does not change from decreasing to increasing or anything like that. It's actually decreasing through the origin. The only place where it changes from increasing to decreasing or decreasing to increasing is right here at x is equal to 3. That's where our local minimum is. So if you were to sketch it, this would be our curve. Now, you should be able to tell where the points of inflection are as well. At 0, 0, right, here's an inflection point. The curve changes from concave up to concave down. And at x is equal to 2, changes from concave down to concave up. So it may be helpful to remember the definition of concavity. All right, if the curve is concave up, this means that the curve is always lying above the tangent lines, and if the curve is concave down, the curve is always lying below its tangent lines in that interval. And see then again at x is equal to 2, if we draw more tangent lines, we see that from 2 onward, the curve is always lying above its tangent lines, hence it is concave up there. So keep doing more of these types of problems and let me know if you have any questions.